Today we're going to use a card sort. We will be able to relate plate tectonics to the formation of crustal features, and we will be able to describe how plate tectonics causes major geological events such as ocean basins, earthquakes, volcanic eruptions, and mountain building. So here we are looking at a plate boundary. Those are indicated by those dark lines, and you're going to look for the number. So this is plate boundary 1, and you want to look at the arrows to discuss the plate motion. So here the arrows are coming together or colliding. So you would take letter M and you are going to drag it over here into the red box and drop it in there to indicate the motion of the plates. Now that you know the motion of the plates, you're going to name that type of plate boundary. And where you have two plates coming together, that's called a convergent boundary. So you're going to drag the card letter P over into the red box. Now, this map is a little difficult to see, but you can make out your North American plate up here. And so this area from our studies is indicating the Aleutian Islands up in Alaska. So we understand what we have here is an oceanic plate colliding with another oceanic plate. And I indicated that with the two red O's up here. So knowing that it's an oceanic plate converging or colliding, we can now talk about the crustal features that form here. So what you get are volcanic island arcs. So you would go ahead and drag and drop that letter G over into the red box. Now these up in Alaska are all volcanic island arcs up here called those Aleutian Islands. So we can say also that we are getting volcanoes as a crustal feature. So drag and drop that. And that is pretty much it. We had 4 correct answers. Again, those answers were converging, and you want to use letter M to indicate the motion. And then we have island arcs and volcanoes. Note always too, when you have an oceanic plate involved, you're always going to get a trench, but trenches are not an option here. So now let's have a look at plate boundary 2. So here, let's look at the map first, and you kind of want to make out, well, what is this a map of? So you have the North American plate here. So you can understand this is California, and here you have an oceanic plate. The Pacific Ocean is here on the Cocos plate. So looking at the arrows, you would indicate the motion, and so that would be letter K, so you'd want to drag and drop that over there. And what you have are 2 arrows sliding past each other. And so since this is California, you guys are very well aware that the San Andreas Fault is located here. Okay, so what we have here is, again, a transform boundary. So drag your motion, and you also want to state that it's transformed. So we want to drag letter O over there as well. So what type of crustal features are going to form here on a transform boundary? You're going to get a fault here, which you would drag and drop as well. And earthquakes. Now, earthquakes are not a crustal feature, it's more of a happening, but transform boundaries are known for the faults and the earthquakes because they're very active sites. So earthquakes would be dropped there. Note also at every plate boundary, you're always going to have earthquakes as a process. So that summarizes our 4 correct cards. Again, we had transform, and that's when 2 plates slide past each other. We're going to get faults and earthquakes. So going on to plate boundary 3, here I give you a clue, oceanic plates. So let's have a look at our map here. So here, this would be your European plate, your North American plate. Down here I can see the African plate. These arrows are giving me a big hint. Okay, so these arrows are moving away from each other. So we want to find that motion, which would be L, and let's drag and drop that over there. When we have two plates moving away from each other or dividing, we say that's a divergent boundary. So we would drag and drop divergent to name our motion. Now, since it's an oceanic plate, we have the ocean dividing, okay, all up and down here. And the crustal formations that you get are always going to be volcanoes. So we want to drag and drop that. And that would be underwater volcanoes happening on that ocean floor where magma is coming up. Since magma is coming up, we would get new crust forming. And the actual crustal formation is called a mid-ocean ridge, which would be that pretty much that crack, that divide in the middle of the ocean, because we have the North American plate moving away from the European plate. So in summary, we have 5 correct answers. We want to start with our motion, which would be L. We have plates dividing, so that would be called a divergent boundary. And then our crustal formation, we would get volcanoes and mid-ocean ridges. New crust is also forming there as well. And our last plate boundary, I gave you the hint of continental plate. So let's have a look at our map. Okay, so I have the Indian plate and the Eurasian plate. My arrows are indicating the motion, so we want to drag over card M into the red box. So when we have plates coming together, we say it's convergent because they're colliding, right? So you have a continental land colliding with continental land. So what you have here is no plate is more massive or more dense than the other. They just kind of fold on top of each other. So our crustal formation that we're going to get here are mountains. Okay, and then here we know our famous mountain range would be the Himalayan mountains here. So the 3 correct answers here, you would use your motion M, that's a convergent boundary, and we're getting mountains. And lastly, we're going to read the passage below and respond to the following statements on the next slide. So the Aleutian Trench is an underwater feature near Alaska formed by the movement of two tectonic plates. The trench between the Pacific Plate and the North American Plate is 2,200 miles long. It is between 50 and 100 miles wide and reaches depths of 25,000 feet in some places. So here we can see the Pacific Plate here. We have an oceanic and an oceanic colliding, and this would be your Aleutian islands and trenches. So when you have an oceanic converging, your more dense oceanic plate subducts underneath the younger oceanic plate. Remember, when oceans are involved, you're always going to get trenches. Okay, and then these are those island arcs up in Alaska where you see. So the North American Plate, California would be down here. It's not showing on the map, but this is a beautiful picture of Alaska. You can also see here a very active site where we have this plate boundary. So we want to identify the type of plate boundary that formed the Aleutian Trench. And you're going to just type here. So you'll type letter A. The plate boundary would be a convergent plate boundary, right? That forms the Aleutian Trench. Describe the geological features. So there we're going to get those beautiful volcanic island arcs. And if we see, it's forming an arc shape, and these are all volcanic islands. And of course, another feature would be a trench occurring at this boundary. Explain the interaction between the tectonic plate processes occurring at this boundary. So the process is going to be subduction, where you have the older, more dense oceanic plate subducting underneath the younger oceanic plate. And that is subduction. Okay, so here in the yellow box, you're just going to type your answer for A, B, and C. Okay, so that was the instructional video helpful for you.